in and an enviable spot of being real close to you in cocktails, so we'll try to keep this as interesting and informative as possible. So they're just getting some of the technology set up here. So title may be a little bit misleading, what we're going to speak about today. It's really about an integrated system for service, but thematically, the theme here is, and we heard it resonate, I think, through most of the conference, how does Internet of Things and device information get incorporated and utilized into the system for service? We heard it this morning, as part of the kickoff, but hey, the train is leaving the station relative to IoT. We heard the gentleman from Juniper Networks speak about getting device and asset information to both your services teams and engineering teams is relevant. So we'll speak about the system, but we'll do that in context of really leveraging interesting and compelling device information. Okay. So by way of agenda, I'm going to start with, very briefly, the evolution of a services model and what outcome-based service organizations are trying to do today and why rich asset information is incredibly important for that type of model. As I mentioned, we'll spend a lot of time really focusing on Internet of Things. How big is it? I'm using the term here, explosive. Let's go through some data and see if you think it is explosive. We'll share a couple of focused application areas. So, okay, it's explosive. What does that mean for services? What does it mean for service applications and service practitioners? How do we start to leverage that information? And then we'll try to close again with a brief prototype demonstration that shows a bit of a day in the life. We'll think about a technician and really bring together all the different aspects of the applications, tools, knowledge that a technician needs in a system for service which incorporates device information. Some information from Deloitte, 2013. Deloitte, big brand strategic consulting firm. The world is in the midst of a paradigm shift in manufacturing, one that integrates a diverse set of ideas, products, and services globally. I think we would all agree, the day that OEMs are selling products without really paying attention to services, probably not very successful companies, right? So there's a bit of a continuum that we've experienced that organizations are going through. We can spend a day just on this slide, but at the highest level, organizations initially started out truly as a product model. They sold a complex piece of equipment. Oh, by the way, since I'm selling that equipment, I probably have to have a service organization to service it. Really not paying a whole lot of attention to services. Necessary evil of doing business. They've gravitated to understanding the profitability and revenue stream from service parts. Gravitated then to let me incorporate some labor with a break-fix model. Evolved into service contracts and SLAs, and to the furthest right-hand side, true outcome, customer outcome-based models, PBL agreements, performance-based logistics. In A&D, Rolls-Royce, GE, Pratt & Whitney, if there's any A&D people in the organization, selling power by the hour. I'm not going to charge you for spare parts. I'm going to give you a 25-year contract that says, you airline fly that system, and you give me X number of dollars per engine flight hour. The example that I think I used yesterday with Train, they're not selling a compressor unit, they're selling comfort. We're going to guarantee you, building manager, that we're going to provide comfort at 68 degrees for your top 10 floors. Medical diagnostic imaging, number of images per hour that MRI machine is generating. As an OEM, if you take that leap and you own a 20 to 25-year contract, guess what? You better get it right. There is an enormous amount of risk with that kind of proposition. There's an enormous amount of profitability, but you better make sure you understand that asset performance before you are willing to commit your organization to that kind of financial exposure. So to do that, we would argue that you need to really understand the asset. What is the service history? What's the asset utilization? How is the end customer actually using that device and asset? Are they adhering to the guidelines and norms of the way you want them to operate it? What's the configuration of the asset? You need to understand all that before you have the ability to really get into a right-hand side offering on this slide. So that kind of leads us to Internet of Things. Understanding the asset, I think we'd agree, why don't we leverage that device that's tweeting at us constantly, telling us how the customer's using it, telling us how and which features are relevant, what are the conditions it's being used in, what's the service history. So Internet of Things, as it states here, is, and I'm just going to go through the tagline here, uniquely identifiable things connected through an internet-like communication infrastructure and to a computing infrastructure. If you take this back to our personal lives, how many people in the room are wearing a Nike Fuel Band or a Fit Band or have at least heard of it? Show of hands. Connected product, right? Not necessarily for service, but it's in our personal lives. How many people have heard of Google Nest? Another example of day-to-day life connected products. Smart cities, smart grids, smart utilities, all connected sort of product examples. As we take it towards services in our equipment that we're servicing, again, I use the example of remote diagnostics with the aviation industry, engine providers. What we're showing on the screen here is actually a John Deere application. It's called FarmSight. So FarmSight is taking devices that are implanted in the ground, which are providing soil-related information. What's the pH of the soil? What's the moisture reading of that soil? They're bringing in satellite imagery. They're bringing weather information and providing an application that basically helps farmers get better crop utilization and better yield. When should I irrigate? When should I harvest the crop? What fertilizer and how much and in what recipe should I use? All being fueled by information coming from, in this case, instrumentation that's actually embedded in the soil. So what? Is it big? What is all this Internet of Things? How big is it? McKinsey's study right here would indicate that it's about to have a $6.2 trillion, with a T, impact on global economic value. Global economic value measured by an accretive dollar of revenue or a reduction in cost, adding up to that $6.2 trillion. It's kind of hard to get your head around a number with a T. One point of view, it's McKinsey. What are some other folks saying? Well, before we leave McKinsey, if you can't get your head around the absolute value of $6.2 trillion, here's another interesting way that McKinsey depicts what's happening with IoT. It's ranking their, quote, disruptive technologies. Number 1, mobile internet. Number 2, automation of knowledge work. Number 3, Internet of Things. Ahead of, for example, cloud technology. Ahead of advanced robotics. Ahead of 3D printing. So it sort of tells you, from a pretty credible third party who does a lot of research, what they think is happening and where IoT is going. Again, the same thread from this morning, the trains leaving the station, I think as practitioners, we have to figure out how to take advantage of that in our services models. Some other alternative points of view. That was McKinsey. Here's a quote from Cisco, Rob Lloyd. The value at stake of the Internet Internet of Everything, is what they frame it, is $14.4 trillion. Similar point of view from a gentleman at GE, pretty reputable organization, about a $10 to $15 trillion opportunity. Is that big? I think so. Here's a chart that shows the GDP of some of the major countries in the world. US at 17, China at 10, Japan, etc. Be the second biggest superpower in the world if we can actually think about ways to harness that sort of $14 to $15 trillion. Now, granted, this 14 to 15 trillion is not just connected products in our world. It's everything. It's Google Nest. It's the fuel band. My point is, it's a big number. And how that relates to connected products and how we service those connected products is a big opportunity. So I'm just kind of piling on a little bit with some of the messages we heard this morning on, yeah, it's relevant, it's here. It's a theme that I certainly keep hearing. So as you think about connected devices and how many are out there and where it's going, here's a chart that says in 2010, there were approximately 5 billion people that were connected. Facebook, Twitter, you name your social media of choice. And about 1 billion connected devices. 2020, that inverts. About 7 billion people in the world will be connected with about 50 billion devices. 2035, it's about 1 trillion connected devices. Whirlpool has about 6 million connected appliances out there. Major OEMs are all embedding smart sensors in their equipment, leading to 1 trillion connected devices. That's the opportunity. You could argue, however, here's the same chart, that, hey, Steve, this is not new. IoT's been around for 20 years. What's so different now? I think what's happening is, and I'll call it IoT 2.0, there are terabytes of data that's already been collected and streamed down from connected devices for years. I think you can make an argument that organizations have not done a good job leveraging that data. So to support 1 trillion devices, what kind of applications do you need to start to think about leveraging that data? Ratio of about 5 million apps are going to be required to support and get leverage from the 50 billion connected devices. And then you can play that out exponentially out in 2035, where you need about 500 million applications. So the point being is, we have the information, we have the infrastructure. We need to start to think about applications in the context of our services delivery that starts to take advantage of it. When we do that, I think, and you saw that example with the Deer Farm site, I don't think it's good enough just to take device information. It's interesting, but taking device information, combining that with people information, i.e. social feeds, taking into account other enterprise feeds and information, bringing all of that context together, right? The Deer site was a great example. Satellite imagery, sensor information on the ground to measure and monitor the soil, other ERP sort of information. That's where you start to get some pretty interesting applications that you can build to actually go do something with. And I'm going to share some, granted in the time we have, some pretty high-level examples of some service applications that start to leverage some of this device information. And here's sort of a continuum, right? Switching gears to now, actual applications. Far left, remote health monitoring. Pretty straightforward. I'm not sure it needs much of an explanation. We have a device, it's giving me information. I can use that information to see how my asset's performing. I can maybe do some remote diagnostics, avoid a dispatch, inform my clients of how their information's doing, perhaps provide, our clients with the ability to self-diagnose. The middle column, auto replenishment, auto diagnostics, auto rescheduling, start to become embedded in our current applications. And on the far right, getting to this notion of a system, we integrate all these applications together, in addition to having asset information, to start to do some things like reliability-centered maintenance and condition-based maintenance. And I'll spend a little bit more time on each of those. So we think about standalone solutions. Granted, I have 30 minutes here, so I'm going to keep this very high level. But automatic replenishment, service parts management sort of tools that many of us have. The genesis or the foundation of that is, I need to have a good forecast. Forecasting spare parts in the service environment is incredibly difficult. We all know that. What informs that forecast? It's an integration to an ERP system. I need to understand usage information. There's always a time delay. How accurate is the information in that ERP system or wherever you're getting that feed from? What if you had information coming directly off a device? So I know real time the exact utilization of the assets deployed globally that then feeds my forecasts and, oh, by the way, does automatic replenishment. Simple example. Middle column is automated diagnostics. I have a sensor, throws an error code, throws a reliability limit, sends a message to my embedded knowledge management system. Knowledge management system understands what that error code means, can either provide that call agent the ability to resolve it, to have the customer resolve it, or request help through a ticket generation in the CRM system, right? That's happening without an intermediary, without someone having to go utilize that knowledge system. It's embedded into the knowledge diagnostic system from the get-go. Same thing on the right-hand side, which is really more of a dispatch and optimization sort of application, field service. I send a code through an IoT platform. The IoT platform sends a message through integration with our field service management scheduling system. Error code A for model B, in this condition C, Field service is smart enough to know that asset's going to fail in 15 hours. Make sure FSM scheduling system, you send a technician with this skill set who understands that model, who can fix it within this SLA. No one's ever touched that ticket. There's not a call agent. There's not some scheduling and dispatch personnel. It all happens automatically. So here's where it gets interesting. Those are some pretty simple examples. The far right now is kind of the holy grail. Reliability, the middle box there, reliability-centered maintenance and condition-based maintenance, right? This is where I think we all want to try to get to. So preventive maintenance schedules, here's the example, right? We have a machine throwing a signal to an IoT platform. We're now thinking about a system of applications, knowledge system, a tech information procedural system, some quality information where I can start to do some statistical analysis, root cause analysis, process entitlement. That enables me, for example, now to say, with that signal information, recharge my helium system every 400 scans. So unlike just having a static reliability limit, we're taking sensor information and asset information and dynamically updating that preventive maintenance schedule, right? So it's not per unique instance of an asset. It's really for your fleet, but it's dynamically updating what that preventive schedule needs to look like. You take that another step and think about reliability-centered maintenance. Now I'm actually optimizing for an instance of a product, not for a fleet of products. So in this case, recharge the helium system every 452 scans for machine 1 and 492 for machine 2. What I've added here is the incorporation of install-based data. So in order to do this, I need to know exactly what's happening at that machine. Again, how is it being utilized? What conditions is it operating in? Is the end operator staying adhered to the guidelines of operation? What's the service history? What's the configuration history? The configuration history is obviously going to have a big impact on when you have to service that particular instance. And then further, same sort of thing with condition-based maintenance. So in this case, it's not a strict reliability limit, it's a condition. Recharge the helium system when the temperature exceeds X or varies by Y during operation. Reaching those two columns on the right, big cost savings. We're automating things, we're not repairing or dispatching technicians prematurely to fix a certain asset. So that's kind of a granted high level. IoT, how it's starting to get embedded into our service applications. If we now think about the system of service, I don't want to just deploy a knowledge system. I don't want to just deploy a parts system. I don't want to deploy just a field service system. Or how do I get my procedural information and parts catalog information? What I think we want to do is allow a role, let's call it a technician, to get contextual information unique to the ticket or task that they're performing, inclusive, again, of device information. So, I mean, this is a fairly common picture. We have technicians out there that have to operate in 3 to 7, perhaps, different applications. I've got a mobile device. I'm going to get my ticket information. It's wonderful. I got a great schedule. I got a route, and I know where I'm going. Now I get on site. I need to get specific knowledge about the task I'm doing. Replace the hydraulic pump. Well, that's great. What specific procedure and what specific part do I need for that variant and that model? I need all that technical information. Point here is that they're involved in a number of different application interfaces. We need to consolidate that and get to them information that's relevant, including device information in context of that system. So here's the example, right? There's a fault warning that's thrown from the device, goes up to an IoT platform of some sort, where error codes and usage and conditions are relayed to the platform. The knowledge base takes that information, utilizes some diagnostic rules and maintenance schedules to identify what action is required. Based on that, if we can't self-diagnose or remote diagnose, we may have to dispatch. We open a field service ticket and a technician is scheduled. Requiring service information is now located and attached to the service order for the technician, so they're not having to search. It's already appended automatically to that ticket. Service is performed, the asset is returned to its proper condition, and all of the respective back-end knowledge systems are updated. So let me share with you, if I could. I've got about a 5-minute, which I think is interesting, prototype of day in a life. I'm a technician. That's a great PowerPoint slide. What would this actually look like? You know, how would a technician actually get value out of a connected system like this? Okay, so here's a technician interface. Technician comes in, they can see their service orders, they can see and search service information, find a solution, look at service sessions. They may get a view of today's route, pretty classic field service application. There may be a calendar widget on the right so they can see their events in the calendar view. They may come in and say, okay, show me all my service orders. Here's my orders for today. Again, sort of classic field service. Show me my service orders overall, not just for today, in everything I have to do for the next 2 weeks, sorted in this case by hospital. We have some site details about the particular site, some embedded device information, what devices, what's online, what usage. I can get more specific about a model. What I'm showing here is actual streaming real-time information on certain parameters. I can get historical information on the right-hand side, the ability to reference any kind of chatting and blogging that was done around that device. Technician will accept this particular order, get details about the job, what's being replaced, when's it scheduled, what's the estimated repair time, some specific client demographics. I can see the tasks on this work order are 2. There's a PM event, and there's a preventive event, replacing the motor. I can take a look at the PM and look at my parts. Pretty simple example. What are my parts for that event? What's the procedure? Here's a list of the individual tasks that technician needs to go through to do the event. Now, this technician's preparing at this time. They're not actually on site. For the reactive event, here's the different parts that I might need. And then we're going to show the ability to maybe add a part. So we're looking at a dynamic electronic parts catalog. And then I want to look at the actual procedure. This could be a textual procedure. What we're showing here is an animation sequence. It's a disassembly procedure. What's interesting is the tech didn't have to go search through 10,000 manuals. The tech, because the system knew it, delivered that exact procedure they needed for that model. And again, it could be textual, but we're showing here an animation sequence, which is graphical. I think people understand and learn and receive better in a graphical type mode. I want to see specific device information real time of the model I'm about to repair. So we can see some of the streaming information below. I may want to select on motor amperage. I see the actual signature for that amperage. Again, leveraging some of that M2M device information. And what's the service history? I want to know exactly what was done on this asset, by who touched the service order, what did the call center agent do, what knowledge articles were referenced, who dispatched me. And now I'm on site, hypothetically. I'm doing the procedure. I'm going to go through the checklist here, remove the table. I've checked the system logs, et cetera, and just go, again, classic sort of field service interface here. I come to a step that says record vibration signatures, what's my minimum value, what's my average value, and give me my maximum value. When I hit my maximum value, I get a display that comes up and says, you've exceeded the threshold. So I know you're repairing this, but something else is going on. Open a knowledge session. Knowledge session comes open, says, well, what's the issue? It's a vibration signature. What does that signature look like? I don't know. Go interrogate the machine and tell me real time what that signature is. Device information again. Yeah, it looks like that middle request. Let me select that. Based on that, this is the solution that I need to go resolve. Technician looks at it, communicates to a field service solution, says, can you add this to my itinerary? I'm here opportunistically. Hypothetically, the schedule agent says, yep, we can do that. We'll reroute other events. Tells them when the parts are due. Shows them, again, the specific diagnostic solution, in this case, replacing the table rails. Shows them the parts that they need for that repair, with an indication that we've actually delivered the parts to the hospital site so you can do the repair. And then you close it. You close the ticket, right? This is, again, sort of a classic debriefing of a ticket that you might see in any field service application. We've done the top 2. We might want to run a verification test, directly interfacing with the machine again. IoT. Yep, everything's green. Let me just debrief the status. We completed the work. We completed the work with parts. It was standard time. I think we're going to select here. The solution I used and is verifying is, yes, you told me a solution. I did, in fact, use that. Go update the knowledge base, and I mark the task as complete. So high level, but hopefully an indication of how different systems work together in context so a tech does not have to waste time searching. It's delivered in context to them, in addition to leveraging some examples here of how machine information gets embedded into that system. So in summary, connected products are here. The train's leaving the station. I think we all have to get on board. You know, an analogy I heard, which I really like, is if we don't get on board, we're going to wake up in 5 years and you're either going to be Borders or you're going to be Amazon. Who do you want to be? I mean, I kind of think that's where the world's going. Those who don't get on board are really going to be left behind. I hope there's nobody from Borders in the room here. They provide intimate, real-time, and valuable knowledge of complex and ever-changing products. They support the trend towards outcome-based service models, which I addressed in the beginning. To do that, you need to leverage a bunch of different asset information to be credible and to avoid the risk that you're about to incur. And it needs to be embedded and integrated as part of the total system, not as a one-off, just go give me device information. What do I do with it? It has to be developed into the system. Service technician ask, at least the ones that we deal with all the time, is something like this. Please, service leadership, show me all the information, actions that I need, yet only the information and actions that I need, which, by the way, should include rich and always-on device information in the best available formats, regardless of where and how I request them, and please, please keep it simple for me. If we can do that for a technician, we've succeeded. We'll get productivity, we'll gain customer success, customer satisfaction, et cetera. So that was all I have. Questions from the audience? Anyone? Make sense? Is IoT, let me see, I mean, does everyone think IoT is relevant? Yeah.
My question was regarding the example you used, the PET CT scanner. Do you run into roadblocks trying to get these types of connected devices into heavily regulated environments such as hospitals, and how have you overcome those roadblocks?
Yeah, you have to be very cognizant of that for sure. And there have to be certain protocols that you go through to make sure you're adhering to the privacy policies. You know, example that I had used yesterday is a company called Seismex. You know, they're in that, they're blood analyzers, so they're subject to the same sort of FDA oversight and compliance. And you know, you have to work with those organizations to say, look, this is only, you might have to give me a new IP address every time I want to go connect to that machine. I'm not going to give you a sort of repeatable IP address. So I think the answer is yes, you have to be very aware of it. But it certainly is doable, right? And the medical device industry has done a really nice job with leveraging IoT. So it's yes, but I think it's just a matter of having those conversations.
You know, maybe in 5 years you don't have to run with the mic because we are all going to be connected.
Yeah.
But from your perspective, do you see how it impacts back to the design of products?
Yeah, absolutely. It's a great question and a great point. I should have hit on that. So we today speaking about using that information to be more effective in your services world. But as a design engineer, I mean, understanding how that product is being used is incredibly valuable. So I'm designing a new product with a set of features in an automobile. I might start to get information from the usage of that automobile. This is, I spend a lot of time, money, and resources developing those 3 features. By the way, only about 1% of the population driving the vehicle ever uses it. The next vehicle, get rid of those features, right? It'd be interesting to know the reliability of those products. I think a lot of times designers design a product, they launch it into the field, and it's like, you know, going around the other side of the sun. You'll lose sight of it, right? So until it comes back around. So quality, feedback loops into engineering, feature usage, warranty compliance, infant mortality, all things that design folks should be thinking about, incredibly powerful, right? Yeah, it's a great point. Okay? Thanks very much.